70-740 Lesson 15, Implementing High Availability and Disaster Recovery Options in Hyper-V. What the heck does all that mean? Well, it means being able to keep your Hyper-V infrastructure up. We've looked at how we use Hyper-V in a cluster, right? Well, there's other ways that we can be able to move our virtual machines around, make sure that they stay up. Because of the ease with which virtual machines can be created and the speed with which the services they provide grow, VM management can quickly become a problem. What does that mean? What that means is, how long does it take me to turn up a new server? I can have a new server running in 5 minutes, operational. In fact, I could probably have it joined to the domain and be installing roles in that amount of time. With the ease that you can add virtualization, you're going to consume storage, you're going to consume processing, you're going to consume memory. It can create sprawl. And then what happens to those VMs that aren't used anymore? They just sit there consuming resources, i.e. storage, that's not being used. When this happens, you need a way to move the VM and its storage quickly and with as little inconvenience as possible to your users. I mean, we've already demonstrated what they're saying here. As a server administrator, VMs are one of the best tools to use for providing functionality on demand. Your boss comes to you and says, hey, we need to do this and I need a server that can do it. Okay, no problem, boss. Give me 10 minutes and I'll have it ready for you. You're a hero, right? And with relative speed and ease, you can deliver additional applications as soon as they're needed rather than waiting for the purchase of new hardware. This is the great benefit of virtualization. Now, what happens is with these growth scenarios, when a more powerful server or more storage space is required, because that application started as a VM, it can get moved to that more powerful server or larger disk with relative ease. So if you have a storage solution that you've been putting your VMs on and it's starting to run out of room, we have the ability to move those virtual machines without breaking them. We can move an entire VM. Beginning with Server 2012, we can use what's called live migration. That's moving the virtual machine while it's still turned on. How about that? There's three basic processes that we can use to move a VM or parts of it. Live migration, quick migration, storage migration. Live migration and storage migration work without a cluster. The quick migration is done using a cluster. So understand that live migration is the process of moving a VM or its storage from one physical server to another without turning off the virtual machine and without any perceived or actual downtime. The VM keeps running. In prior versions, the process of doing this required that that virtual machine be hosted in a clustered environment. Not anymore. Since Windows Server 2012, you can do this. You can do the live migration without having to have a clustered environment. How do you go about that? Well, you do that using a process that's sometimes called shared nothing migration. And this is because that storage is mirrored over the network to the destination server while the VM continues to run and provide its services. You have to configure those live migration prerequisites, the live migration security, how you're going to do it. Are you going to use what we call constrained delegation? You have to configure the source and destination computers, the hosts where that migration is going to take place and go to. And then actually move a running VM or VM storage. Now, you have to provide some type of authentication. You need to have at least 2 Windows Server 2016 servers that are running Hyper-V. We can't move a Hyper-V virtual machine off of Hyper-V and not put it on another Hyper-V, right? That's just common sense. Those two virtualized servers, those two hypervisors, they have to use processors from the same manufacturer. They all must support hardware virtualization. They've got to be in the same Active Directory domain, or they could be two domains that trust each other. Can't be in a workgroup. It does not work with servers that are in a workgroup. Those VMs must be configured to use either a VHD, a VHDX, or fiber channel disks. It is recommended that they use a private network dedicated to that live migration traffic. When we do a live migration, we have the ability to control what network we want the traffic to be placed upon. They've got to have membership in one of these groups, the administrators, the domain administrators, or the Hyper-V administrators. And then additionally, you need to ensure that you've got the Hyper-V remote management tools installed and that they're configured that you can remotely manage both of those hosts. Now, how are you going to perform the actual migration? Will you do it from a keyboard, from a video and monitor switch, from a KVM? Or will you do it through an attached monitor session? Are you going to use remote desktop? Are you going to use your remote management tools? Or are you going to use PowerShell? This is going to determine whether you're going to use CRED SSP, that's Credential Security Support Provider, or Kerberos. If you're not going to use your remote management tools, you have to sign on to that source server and use the CRED SSP. If you can use remote management tools, you'll configure what's called constrained delegation, and you'll use Kerberos as that authentication protocol. Here are the steps for going through configuring constrained delegation. Now, when it comes time to actually configure the source and destination for live migration, you'll go into your Hyper-V settings and select live migration and enable it. You click the live migrations, you enable the incoming and outgoing. You then have the option to expand the advanced features, and that's where you determine whether you're going to use Kerberos or that CRED SSP. You then can go back into your live migrations and you can determine what network you're going to use for that migration traffic to take place on. You don't want to interrupt your production network where all your other traffic is being placed. So this would give you the option, if you have a secondary storage network, you might be able to use that to move your VMs. And of course, like most everything else, you can configure and manage that live migration using PowerShell. We can monitor that migration, and when we go to do it, we go into the interface to move it, and we select, do we want to move the virtual machine and optionally its storage, or do we want to just move only the machine storage? You don't have to move everything. You can move just the storage. It may be that you want to keep the configuration files local, and maybe you need to move the storage from one SAN to a different SAN, from one storage array to a different storage array. Depends on your need. Your options are move all the virtual machine's data to a single location. You can move that data to different locations, or you could move only the virtual hard disks. And here's those simple steps for moving a VM to another Hyper-V host. Now, you can also do a quick migration. It's another way to move a running VM from one physical host to another. However, remember at the beginning we talked about this, quick migration only occurs within the confines of a cluster. Now, you can also implement storage migration. Here again, storage migration is another way to move that VM data without disrupting users. And here would be the steps to perform that. Now, Hyper-V Replica. Here we start to move into the realm of disaster recovery. being able to recover a virtual machine in the case that a site or a hypervisor goes down. The reason that you perform backups is to be ready when you need to perform data recovery. And using clustering, we can provide fault tolerance for our servers. We've demonstrated that in our previous lessons. However, when disasters occur that cause that cluster to fail, or the VM or the data that you have on the central storage device to become corrupted, it takes time to perform any repairs and restore it from backup. What happens if an entire site goes offline? To help overcome this problem, Hyper-V Replica was created. It's what we call an offline copy. It allows you to create a Hyper-V virtual machine from one host at a primary site to another host at what we call a replica site. The VMs are mirrors of each other. One is online, one is offline. That replica is used as a spare server, and it gets stored on another storage device at another site. You would also consider this a cold server because it's turned off. It's off until you need it. However, while you're not using it, that replica continues to be updated. So when the time comes, you have an updated virtual machine that you can turn on to replace one that went down. To do this, it keeps the replica updated by tracking the write operations on the primary VM, and it replicates those changes over to the replica using some type of wide area network link. If in case that primary site does go down, you can bring that replica server up in minutes. I mean, it's simply a matter of right-clicking it and starting it. To do that replica, it uses a couple different components. It uses what's called a replication engine, change tracking, a network module, and then also what's called the Hyper-V Replica Broker Server role. The replica engine, it's the component that manages the configuration details of that replication. It manages the initial replication, what's called delta replication, failover, and test failover operations, because we also have the ability to test our failover, make sure it works. If you can't test a backup process, you don't know whether you can rely on it. It's critically important that you be able to test your backups, and in the same case, be able to test your failover. Change tracking is the component that tracks the changes from the primary copy of the VM. And it tracks the changes regardless of where that VM's VHDX files reside. The network module is the component that provides a secure and efficient way to transfer those replicas between your primary and replica hosts. It uses compression, it can use encryption, all ways to make sure that it is secure. The Hyper-V Replica Broker Server role, it's a new server role that was introduced back with Server 2012. And what it does is it redirects all virtual machine specific events to the appropriate node in that replica cluster. It's used with clusters. Understand that. It's configured as part of the failover cluster. If you're going to use a Hyper-V replica, first and foremost you have to enable the replication between two Hyper-V hosts. You'll configure the replication of one or more virtual machines, and you'll test that replication deployment. Now, you want to use, in any case it's possible, you want to use certificates. You're going to use an X509 version 3 certificate, or you might create a self-signed certificate if you don't have a certification authority running. Keep in mind that using that certificate can't be expired or revoked. It's got to include both the client and the server authentication extensions and an associated private key. And it must terminate at a valid root certificate in your Trusted Root Certification Authority store on the replica server. If the VM is hosted by a standalone server, The common name, that's the subject common name, the CN, contains the fully qualified domain name of the host, your FQDN. If that VM is hosted by a failover cluster, that CN should contain the fully qualified domain name of the Hyper-V replica broker. So going about enabling Hyper-V replication, you follow these steps. You would go in and you would enable this computer as a replica server. You would then define how you're going to do your communications. Are you going to use Kerberos? Additionally, you can use certificate-based authentication. You define that certificate. Keep in mind that you need to already have a certificate provisioned for that server before you can select it. And then if this is the replica server, you may specify to allow replication from specific servers. I encourage you to take a look at the video that I created, which was implementing Hyper-V replication between a host and replica server. It shows a step-by-step process of enabling a replica VM and seeing that process take place. Additionally, you have to enable some firewall rules on both machines. And of course, if you're working in a cluster, you would be enabling that Hyper-V replica broker. You also have the ability to determine when that replication takes place. You can say start it immediately or define when it begins. If you're going to create a Hyper-V replica of numerous virtual machines, you may wish to do your initial replication method by using external media and not your network. You could have hundreds of gigabytes or terabytes of data that need to be replicated. Doing this across your network may not be practical. Depending on the size, you may specify using external media for that first initial replication. Once it has begun, you can view the replica health and be able to verify what its state is. Here again, you can see this shown as an example in that video I just referenced. Now, you can configure what's called VM network health protection. Understand a network outage can have serious repercussions to a virtual infrastructure. For a larger virtual infrastructure, you should always use network teaming to provide network redundancy to help protect against faulty cabling or switches. We've briefly discussed this earlier in our course, but we'll be taking a look at NIC teaming in detail in one of your future lessons. What that does is it allows you to bond connections together, creating redundancy, fault tolerance, and additional bandwidth. Network health protection was first introduced with Windows Server 2012 R2. And remember, just as a point, Server 2012 R2 also coincided with the release of Windows 8.1. It provides network high availability with Hyper-V. What this does is this automatically migrates from one failover cluster node to another failover cluster node if network connectivity on a specific network adapter becomes disconnected. Once you've enabled that network health protection, it checks every 60 seconds to make sure that a network connection is available or not. Once it discovers a disconnect, it then takes action. And here is the steps that you would go about to be able to enable that. This was a fairly brief lesson, but I would encourage you to take a look at the video implementing Hyper-V replication between a host and replica server. It's about a 15-minute video that goes through the processes of setting up two Hyper-V hypervisors to be able to do replication and then do the replication of a virtual machine. Understand that because of the ease with which virtual machines can be created and the speed with which the services they provide grow, our VM management can quickly become a problem. You need a way to move these virtual machines and their associated storage quickly and with as little inconvenience to your users as possible. By using live migration, quick migration, or storage migration, we can move our virtual machines. Specifically using live migration, there's no interruption whatsoever. We illustrated how using a Hyper-V replica, which is an offline copy, allows you to create a disaster recovery solution so that your virtualized infrastructure in a primary site can be replicated as an offline copy of that same virtualization infrastructure in a replica site. In this way, if the primary site goes offline, you can recover your virtual machines and bring them online from your disaster recovery or spare site. And then finally, we briefly discussed how network health protection was introduced with Windows Server 2012 R2. And it provides network high availability to be able to automatically migrate your Hyper-V from one failover cluster node to another if your network connectivity on a specific network adapter becomes disconnected. Thank you for reviewing 70-740 Lesson 15. I'll see you in the next lesson or lab.